Good day. We're gonna present about the AC and DC meter in electronics instrumentation. Introduction. What is a meter? A meter is any device built to accurately detect and display an electrical quantity in a form readable by a human being. It can measure the basic quantities of voltage, current, and resistance. A meter can be visual, motion of a pointer on a scale, or a series of light. How can we measure current and voltage? The D'Arsonval meter movement consists of a movable coil placed in the field of a permanent magnet. Current in the coil creates a torque in the coil, which rotates until torque is balanced by restoring spring. Designed so deflection of the pointer is directly proportional to current in the movable coil. The operation in the D'Arsonval meter movement is the current measured is directed through the coil of the electromagnet so that the magnetic field produced by the current opposes the field of the permanent magnet, which causes rotation of the core. There is a pointer attached for the scaling. The equivalent circuit of ammeter, voltmeter, and ohmmeter. In the DC ammeter, the shunting resistor and the D'Arsonval movement from a current divider. The DC voltmeter, series resistor, and D'Arsonval movement from a voltage divider. And the ohmmeter measures the current to find the resistance. The DC ammeter is to limit the amount of the current in the movement's coil by shunting some of it through the R shunt. The voltage at shunt is equal to the full-scale deflection current of the movement multiplied by internal resistance of the movement. The shunt current is equal to full-scale current minus the full-scale deflection current. And lastly, the shunt resistance is simply shunt voltage over shunt current. The multi-range ammeter. The range of the DC ammeter is extended by a number of shunts selected by a range switch, which shown in the figure is the 1, 2, and 3. The multi-range ammeter uses the Arieton shunt or the universal shunt. The Arieton shunt eliminates the possibility of having the meter in the circuit without a shunt. Switch S, or the multi-position switch shown in the figure, protects the meter movement from being damaged during range changing. The DC voltmeter. A basic D'Arsonval movement can be converted into a DC voltmeter by adding a series resistor, which is a multiplier. V, which is the full range voltage of the instrument, is equal to the full scale deflection of current of the movement multiplied by the sum of internal resistance of the movement and the multiplier resistance. And the multiplier resistance is equal to the V minus Im Rm over Im, which also is equal to V over Im minus Rm. The Rs, or the multiplier resistance, is equal to the full range voltage of the instrument over the full scale deflection current of the movement minus Rm. Multi-range voltmeter. A DC voltmeter can be converted into a multi-range voltmeter by connecting a number of resistors in series with the meter movement. Multi-range voltmeter has the voltmeter loading effects, which are the voltmeter circuit itself is in parallel with the circuit component. Total resistance will decrease, so the voltage across component will also decrease. The resulting error is called a loading error. It can be reduced by using a high sensitivity voltmeter.
Hi, I'm Forlan Briones, and we will discuss the ohmmeter and DC bridge. Ohmmeter is an electrical instrument that measures electrical resistance, the opposition to an electric current. The ohmmeter consists of battery, resistor, and PMMC. As you can see in the figure, that is a basic ohmmeter circuit. Function of RC and RM are to limit the current through the meter. Now, let's go to DC bridge. DC bridge are used to measure resistance, inductance, capacitance, and impedance. Operate on a null indication principle. This means the indication is independent of the calibration of the indicating device or any characteristics of it. There's a two types of DC bridge, Wheatstone bridge and Kelvin's bridge. In Wheatstone bridge, when the bridge is balanced, the galvanometer carries zero current and it does not show any deflection. Thus, bridge works on a principle of null deflection or null indication. In a balanced condition, current flows through the galvanometer causing the deflection of its pointer. Now, let's go to Kelvin bridge. One of the major drawbacks of the Wheatstone bridge is that it can measure the resistance from few ohm to several mega ohm, but to measure low resistance, it gives significant error. To secure increased accuracy in the measurement of low resistance, it is used to measure resistance from few micro ohm to 1 ohm.
What is an AC bridge? The bridge uses the measuring the value of unknown resistance, inductance, and capacitance. It is known as the AC bridge. The AC bridges are very convenient in giving the accurate result of the measurement. The construction of the bridges are very simple. When describing the general AC bridges, where impedances and not just the resistances must be in the proper ratio for balance, it is sometimes helpful to draw the respective bridges legs in the form of box-shaped component, each one with a certain impedance. One type of bridge is the similar angle bridge. The similar angle bridge is used to measure the impedance of a capacitive circuit. This bridge is sometimes called the capacitance comparison bridge of the series resistance capacitance bridge. The circuit shown is the example of similar angle bridge. Another type of bridge is the opposite angle bridge. The opposite angle bridge or Hay bridge is used to measure the resistance and inductance of coils in which the resistance is small fraction of the reactance XL. That is the coil having a high Q, meaning a high Q greater than 10. The third type of bridge is Maxwell-Wien bridge. It is measured an inductor in terms of a capacitor standard. It is used to measure the unknown inductances in terms of the calibrated resistance and capacitance. Calibration grade inductors are more difficult to manufacture than capacitor of similar precision. And so, the use of the simple symmetrical inductance bridge is not always practical, because the phase shape of the inductors and capacitor are exactly opposite to each other. And lastly is the shearing bridge. It is an electrical circuit used for measuring the insulating properties for electrical cables and equipment. It is an AC bridge circuit developed by Harald Schering. It has the advantage that the balance equation is independent for frequency. It is used for the precision measurement of capacitors and their insulating properties, for phase angle is nearly 90 degrees.